Good morning. Video to go over the Unit 8 test review. So let's have at it. Number one, irrational equations shown below. Find the real values of x. And with that, we have to multiply by the least common denominator. And so we have a k minus 3 in the denominator, k minus 4, and then we have k squared minus 7k plus 12. What we need to do is we need to factor this thing right here. All right, and if we were to factor that, what that would end up being is k minus 3 times k minus 4, because negative 3 and negative 4 add to negative 7, negative 3 and negative 4 multiply to negative 12. So we're going to be 3 over k minus 3 plus 4 over k minus 4 equals 25 over k minus 3 times k minus 4. All right. So our least common denominator is k minus 3 times k minus 4. So we're going to multiply both sides by k minus 3 and k minus 4. So we're going to distribute k minus 3, k minus 4 to here and to here and to there, to both sides. So what happens in this first one is the k minus 3 and that k minus 3 cancel out, so we're left with 3 k minus 4. And then over here, the k minus 4 and that k minus 4 cancels out, so we're left with 4 k minus 3. And over here, we're multiplying by k minus 3, k minus 4, and we're also multiplying by k minus 3, k minus 4. So we're going to be left with 25 here. So we condense this down, so we have 3k minus 12 plus 4k minus 12 equals 25. Combine some like terms, so we get 7k minus 24 equals 25. All right, we add 24 to both sides, so we end up with 7k equals 49, because we have to add 24, so k is going to be equal to 7 on that first one right there. Okay, so we got to just factor this so we can see the least common denominator. We multiply both sides by the least common denominator, simplify it down, and just solve for our variable. Pause the video if you need to. I'm going to show you how to do this in the calculator if you want to sort of go the Desmos route. If we wanted to go the Desmos route, so we had 3 over x minus 4 plus 4 over x minus 3. So that was our first graph right there. And the second one, we had 25 over x squared minus 7x plus 12. And we're going to find the x value where they meet. So they're going to meet right there. Was it 25 over? So they're going to meet at 7. I don't know why that decimal is a little off there, but they're going to meet at 7. All right. Moving along here. Find the domain and range of this rational function, and graphing it is kind of the best way to do that. If we wanted to sort of factor the denominator again, we have 8x here, and then x squared minus 13x minus 42, which is x minus 7 times x minus 6. All right, if we were to set the denominator equal to 0, x minus 7 equal to 0, x minus 6 equal to 0, we know that x being equal to 6 and x being equal to 7 would be our vertical asymptotes, because x cannot equal 7 or x cannot equal 6. It'll make the denominator equal to 0. So we know the domain is x is not going to equal 6 and x is not going to equal 7. Otherwise, it's going to be all real numbers there. The range, I would still graph it just to sort of be sure, because sometimes, even though we have horizontal asymptotes, sometimes it could still cross it. So if we come up here, 8x over x squared minus 13x plus 42, we have x squared, 8x over x squared minus 13x plus 42. Okay. We see our graph right here, and it looks like it goes all the way up to the moon, and it goes all the way down here, and it goes all the way up. So it looks like our range is going to be all real numbers. So we have asymptotes at 6 and 7 right there. So again, I would graph those up to be sure. All right, number 3, restrictions of the domain. Okay, again, restrictions of the domain are just going to be our vertical asymptotes again. So we have to set the denominator equal to 0. So if we have, x squared minus 3x minus 130, set it equal to 0. You'll have access to the factoring calculator as well. And so if you want to do it in the factoring calculator, that's fine. If you want to graph it, that's fine. What's going to happen here is we have two numbers that multiply to negative 130 and add 3, which in this case is going to be negative 13 and positive 10. So x minus 13 times x plus 10 is equal to 0, making x equal to 13 or x equal to negative 10 there. Again, if you want to do the factoring quadratic calculator, you could type A1, B negative 3, C negative 130, and it'll spit out your two answers there, 13 and negative 10. We also, if we could, graph it. So we have 9x minus 2 over x squared minus 3x minus 130. So here's our graph right here, and we see, so we're going to have a vertical asymptote here at positive 13. If you see, we're going to approach 13 but never touch. So positive 13. And then again over here at negative 10. Okay. And again, if you want to graph it up, x equals negative 10, x equals 13. You'll see we have these vertical lines here that the graphs are going to approach, but they're never going to be able to touch. Okay. So you can do it by hand, you can graph it, you can go into the quadratic calculator after you set it equal to 0 and find the restrictions on the domain that way. All right, number 4. Write the 3 possible explanations for the denominator of a function that has a vertical asymptote at 5. So if we have a vertical asymptote at 5 and the denominator needs to be equal to 0, I mean, we could do x minus 5, or we can go, 2x minus 10, or 3x minus 15, any x value, or any expression where if we plug 5 in for the x value equals 0. So you can kind of go nuts with that if you want to there. Okay, the cost per person to rent a charter bus varies inversely on the number of people who ride the bus. If 40 people pay $7.50 each to ride the bus, what is the cost per person if only 24 people go? Okay, so inverse variation here. So we have y equals a over x. We got to find our a. Our a is going to be x times y. Okay. Whoops. So we're going to multiply 40 times 7.5 because those are our x and our y's right now. So 40 times 7.5, I believe, is 300. Let's check. $300. So what's going to happen here is that 300 is going to be the total cost to rent the bus. Total cost to rent the bus, $300. Okay, so 40 people go. All they got to pitch in is $7.50 a person. Okay, because the whole bus costs $300. So what's the cost per person if only 24 people go? Well, the whole bus still costs $300. Then we got to divide that by 24. Okay, and we're going to find out how much each person is going to have to pay if they do, if 24 people go. So we go 300 divided by 24, $12.50. So the more people go, the less each person has to pay because there's a flat rate of $300. All right, 2 more. So 2 people were putting up a fence in the backyard. It takes one person 10 hours to put it up, another person 14 hours to put it up. How long will it take for both of them to put up together? So that's going to be our 1 over 10 plus 1 over 14 equals 1 over x. Okay, simple rational equation. Rational equations, we got to multiply both sides by the least common denominator. The least common denominator is going to be 10 times 14 times x. Okay, so 10 times 14 times x times 1 over 10, so we're going to be left with 14x. And then 10 times 14 times x times 1 over 14 is going to be 10x. So 14x plus 10x is going to be 10 times 14 times x over x, which is going to be 140. So we're going to have 24x equals 140. So we'll divide 140 by 24 to find out how much time it'll take. $5.833. All right, so that's our answer for number 6. Last one. Find values for h and k that show the transformed rational function has a vertical asymptote at 7 and a horizontal asymptote at -4. So if we have a a vertical asymptote at 7. So let's look at the parent function real quick. If we have just 13 over x, if we had 13 over x, the function would look something like this. Okay, we have a vertical asymptote here at y or at x equals 0, and a horizontal asymptote at the x-axis right there. Okay, so vertical asymptote at x equals 7. Okay, we're moving this asymptote to the right by 7. Okay, which means we need a minus 7 on the bottom. So if we have x minus h there, h is going to be 7. Horizontal asymptote at y equals negative 4. So the horizontal asymptote here is at y equals 0 on the pink one. I should do that in pink. That's a horizontal asymptote there. We want to move it to negative 4. So we move it down here to negative 4. So we moved it down 4. So k is going to be negative 4. So now that pink function, if we were to move it, negative 7 is our vertical asymptote, negative 4 is our horizontal asymptote. So now this function will look something like this. Okay, so there's a review. Let me know if you have any questions, and best of luck. Thank you.